All right, so we know that we've been talking about inscribed angles, right? So this is the last section on your test, right? So you're going to see a whiteboard now. Yeah, you all see the whiteboard? All righty, so we know that an inscribed angle is something, an inscribed angle is simply an angle whose vertex, some of you guys got to mute yourself, right? The vertex is on the circle and the sides are chords of the circle, right? So in this problem, angle B is an inscribed angle because its vertex is on the circle. All right, now, we know that the circle is then cut into two chords, right? We know that the circle is cut into two chords. So we have two arcs. So we have arc AC and we have arc ABC, right? Now, if I tell you that this arc here is 60, right? That means this one has to be 300, right? Because all the way around the circle is 60. Now, but more importantly, what do we know about the measure of the inscribed angle that cuts it? Well, the rule is the inscribed angle is 1/2 the arc. So by rule, the measure of angle B would be 1/2 the arc AC, because that's the arc that the angle cuts. Well, in this problem, AC is 60. So what's the measure of angle B? Well, 1/2 of 60 is 30, right? So that's just a review question, right? But we can do it the other way. If I give you the arc, if I give you the angle, you can tell me the arc. So we'll just take the same picture. We just move the angle around. And this time I'm going to tell you the measure of angle B is 57. And I say to you, what is the measure of arc AC? Well, arc AC is cut by angle B. And angle B is inscribed, so we know that the angle, the inscribed angle, is 1/2 the arc it cuts, which means the arc is 2 times the angle. So the measure of arc AC is going to be equal to 2 times the measure of angle B. Well, we know that angle B is 57, so 2 times 57, what's that? 114. All righty? Does that make sense, fellas? Yes or no? And once again,
Sure.
that's just,
Sure.
all right, now, then we started talking about what happens if we have a couple of angles that cut the same arc. So what's that look like? Well, I'm going to draw you a nice little picture. All righty. So this is A, B, C, and D, all right? And I want you to look at angle B, and I want you to look at angle C. So angle B is this angle right here. I'll put it in red. And then I'm going to talk about angle C. And I'm going to put angle C in blue. So sometimes the hard part for guys in geometry is they just see the full picture and they're not able to actually figure out. Now notice what arc angle B cuts. And notice what arc angle C cuts. They both cut arc AC. They're both inscribed, yes? Angle B and angle C are both inscribed angles. And they both cut the same arc. So here's what I know. The measure of angle B is 1/2 arc AC. And I know the measure of angle C is 1/2 AC. Hey, fellas, look. What do you know about angle B and angle C? What do you know about angle B and angle C? Hello? What are those two numbers? Hello?
Those are
They're the same, right? So if angle B and angle C, look at my highlighter, angle B cuts this arc, right? Angle C cuts this arc. That's the same arc. So if two angles cut the same arc, then those two angles have to be congruent. So if I tell you something like this, right? The measure of angle C equals 3x. The measure of angle B equals, well, that's not a good B. The measure of angle B equals x plus 24. Well, if I told you that, fellas, what would you tell me x is? Well, I give you two values using variables. All I got to do is figure out what's the relationship between B and C. And of course, we know that they are what? Equal. And the reason we know they're equal is because they both cut the same arc. All right, so then I just solve that. 2x equals 24. Divide both sides by 2. And I get x equals 12. Now, fellas, that doesn't tell me what the angle is. If I tell you x is 12, what's angle C? Well, 3 times 12. What's that? 36. And then I should get the same thing here. If I put 12 in there, what's 12 plus 24? 36. That makes sense. Hey, fellas, if angle B and angle C are both 36, what's this? Anybody?
that would be
The inscribed angle is 36. What's the arc? 72?
72, yeah.
72. All righty. All righty. One more thing before we move on to what we're going to do today, right? Sometimes I don't give you the information directly. So now you have angle P. And we know angle P is inscribed, right? Now I'm going to tell you arc NP equals 120 and arc PQ equals 100. What's the measure of angle P? All righty, now, here's what they told me, ready? NP, arc NP is from here to here. And that's 120. And then they told me PQ, and that's from here to here. And this is 100, all righty? They want me to find out what this angle is. Well, what kind of angle is P? Its vertex is on the circle, and its sides are chords of the circle. So it's an inscribed angle. Can I figure out what NQ is? Hello?
Yes.
If I started at Q, ready, watch. If I start at Q and I travel around a circle, when I get to P, I've done 100 degrees. When I get to N, I've done 120 more degrees. If I kept going and got all the way back to Q, what would that total be? It's a full circle.
360.
Yeah, it would be 360. So I can figure out what this is right here. I can figure out this number because I know this number plus this number plus this number has to equal 360. And then once I know this number, I can figure out that number. So let's do that. So I'm going to call this X. So I know X plus 100 plus 120 equals 360. So I'm going to combine these two numbers, right? So X plus 220 equals 360. So then I'm going to subtract 220 from both sides. And I'm simply going to get X equals
140.
40. Good. Now, fellas, if this is 140, what's the inscribed angle that cuts that? What's the relationship between 140 and that angle? The angle is half of that. So what's the angle? 70 degrees. All right? Now, that's all stuff you should have known, and that's quick review, right? That's quick review. Now, today what we're going to talk about is just two little rules when we have what we call inscribed polygons. All right? Inscribed polygons. Right? An inscribed polygon is any polygon whose vertices are points on the circle. So that would be an inscribed triangle. This would be an inscribed quadrilateral. All right? So make sure we understand what the word inscribed polygon means. It simply means that the vertices of the polygon are points on the circle. All right? Now, what we're going to talk about today, just two of them, a triangle and a quadrilateral. All righty? And we're just going to talk about using knowledge we already know that actually leads us to this information. Like, for example, if you sat down and looked at these things that we're going to talk about for long enough, you would actually figure this stuff out yourself. Does that make sense? All righty. So the first thing we're going to talk about is an inscribed triangle. And we're going to talk about, you know, there's special things that we know about this, right? Right? There's special qualities about this. Ready? So I'm going to draw you a circle. Ready? And then I'm going to draw you this. Now, what is that? What is that? What kind of line segment would you call AC?
Diameter.
Yes. AC is a diameter. Why? Because it's a chord that cuts through the center of a circle. That's why you put the dot there. Now, pay attention to what I'm going to do. That diameter cuts the circle into two what? What's the diameter cut a circle into? Two semicircles, right? All righty. Semicircle's half a circle, right? All right, good. Now watch. If I put a point right here, I'm going to call that B. And then I make an angle. Now, fellas, what is the arc that angle B cuts?
AC,
AC. Now pay attention. AC is a
semicircle,
semicircle. And what does a semicircle measure?
180,
Ooh, and angle B is inscribed. So it's going to be 1/2 of that. So what is the measure of angle B, fellas?
90,
90 degrees. And that's the rule that I'm going to talk about. If you have an inscribed triangle, triangle ABC is inscribed, right? If you have an inscribed triangle, and it intercepts a diameter, then this angle, that triangle, is going to be right. All righty? Now watch what happens. Watch what happens. I'm going to take the same picture, right? From here to here. Everything's the same now, right? But look what I'm going to do. I'm just going to move where I put B. But I'm going to keep A and C right here. And I'm going to make a triangle. Now, how do I know that's 90 degrees? Because what does it intercept? A diameter. 180. Let me move B again. Ready? I'll move it over here. I'm going to draw a pin. There you go. I'm going to go, there you go. I got a 90 degrees. Anytime your inscribed angle cuts a diameter, that triangle is going to be right. All righty? Does that make sense? So now you can use that. You use that to help you, right? So for example, here's a question you could possibly see. Ready? I'm going to draw a circle. And I'm going to go like this. FH. And H, we know, is the diameter because I had a chord that runs through the circle, right? Through the center, right? I'm going to put a point right here, G, right? And now I'm going to go like this. I'm going to make it a triangle. Now, I know, fellas, that the measure of angle F is 4x plus 2. And the measure of angle H is 9x minus 3. Why? Because I told you they were. If I said to you, what's the measure of angle F? Well, how would you do that? Well, fellas, what do you know about triangles and their angles? What do you know about the three angles of a triangle?
add up to 180,
Good. Now look what I know. I know F and I know H. Fellas, do I know G?
90,
Yeah. How do you know G is 90? What does it cut?
the diameter,
There you go. So now all I got to do is take my information and put it into a equation. So let me get rid of this so I can write down somewhere, right? So here's what I know. I know that the three angles, F, right? Angle F is what? 4x plus 2. Angle G, we said was 90. And angle H is 9x minus 3. Well, those three angles together have to add up to 180. All righty. So now we just follow our rules for solving equations. Let's combine the like terms on the left side, right? Let's combine our like terms over here. So I got a 4x and a 9x. What's that equal? 13x. All right, and then I got a positive 2 and a positive 90. That's 92 minus 3, 89. That equals 180. So those two equations are the same, except one is combined. All right, now solve it. First thing you do is subtract 89 from both sides. And if I do that properly, I get 13x over here, and 180 minus 89 is simply 91. Yes? And then all I do is divide both sides by 13, and I end up with x equals, and I believe I end up with 7. Now, that doesn't answer the question. The question is, what's the measure of angle F? Well, what did we say F was? We said F was 4x plus 2. 4x plus 2. Well, I know x is 7, so I'm just going to go 4 times 7 plus 2. So 4 times 7 is 28 plus 2, 30. That makes sense, right? Yep. What if I said, what's the measure of angle H? Well, I know what x is. We figured out what x is. We know x is 7. Right? We know x is 7. So all I got to do is take what h is. We said h was what? 9x minus 3. So I go 9x minus 3. That's going to be h, right? Well, x is 7. 9 times 7 minus 3. Well, 9 times 7 is 63 minus 3, 60. Hey, look, we got a 30, 60, 90 right triangle. Does that make sense, fellas? All right, let's do another one of those, right? And remember, what are we working on? If you have an inscribed triangle and the angle intercepts a diameter, you have a right triangle. So I'm going to draw you the same picture, or relatively the same picture, right? I'm going to draw something like this. Boom. All righty. So now I have, right? I have F, H, G, right? I tell you the measure of angle F is 7x plus 2. And I tell you the measure of angle H is 17x minus 8. What's x? All righty. Well, fellas, what diagram do you see here? You see a what? What do you call that? What is that?
Triangle.
Yeah, and angle G cuts a diameter. So what's angle G? 90. So what do I know about all the angles? They add up to? What do the three angles of a triangle add up to?
180.
180. So what's F? 7x plus 2. That's F plus H. 17x minus 8 plus 90 has to add up to 180. For the rest of your life, every time you see a triangle and you're thinking about the angles, you know they add up to 180, all of them. All righty, let's combine our like terms. I got a 7x and a 17x. That's a 24x. And then I got 2 minus 8, that's minus 6, plus 90. Well, minus 6 and positive 90 is a positive 84, right? Hello? Equals 180. Yes? Now, solve that. Step 1. Subtract 84 from both sides. 24x equals, what's 180 minus 84? 96, right? What's 96 divided by 24? 4, right? Everybody see that? All right.
Yes.
All righty. So all that comes from, fellas, anytime you see triangles, you need to be thinking 180. But when you have an inscribed triangle, it's a big deal to realize if it cuts a diameter, then it's going to be a right angle. Okay, does that make sense? All righty. Now, the second thing we're going to talk about today, and this is true always anyway, right? Second thing we're going to talk about is an inscribed quadrilateral. All righty. And that just means what? Its 4 vertices are on the circle. All righty. So sometimes they look like squares. They're not really squares. So here's what I know about quadrilateral ABCD. It's inscribed. Why? Because all 4 vertices are points on the circle. Now, what you need to remember is this. If you have a quadrilateral, inscribed quadrilateral, right? So the opposite angles are supplementary. Now, that's true even if it's not inscribed, right? So if I'm looking at this picture, if I look at angle A, fellas, what angle is opposite angle A? Angle C. If I look at angle B, what angle is opposite angle B? Angle D. It's like opposite, right? It's like out on the, oh, what am I doing? So for example, let me just draw a quadrilateral. Angle 1, 2, 3, 4. So 1 and 3 are opposite. 2 and 4 are opposite. So when you have an inscribed quadrilateral, you just need to remember, just like normal, the opposite angles are supplementary. What's that mean? They add up to 180. So in this picture, here's what I know. The measure of angle A plus the measure of angle C equals 180. This should be D, by the way. And then what else do I know? The measure of angle B plus the measure of angle D equals 180, right? Anybody have any problem? Anybody have any problem? With that? You understand what opposite means? You understand what supplementary means? Now, you just have to be able to use it, ready? So how are we going to use it? All right, so let's take an example of how we're going to use it. Ready? I'm going to draw a little circle, right? And inside the circle, I'm going to draw a quadrilateral. So I got A, B, C, D. So before I even start, I have a quadrilateral inscribed. So I know the opposite angles are going to be supplementary. So before I even start, in my head, I know that the measure of angle A plus the measure of angle C equals 180. Because A and C are opposite each other. What else do I know? I know that the measure of angle B plus the measure of angle D equals 180. Why? Because B and D are opposite each other. Does that make sense, fellas? So if I said to you, the measure of angle A equals 60, and the measure of angle D equals 95. And I said to you, what's the measure of angle C? And what's the measure of angle B? All righty, that's easy enough. Well, what do I know about A and C? A and C are opposite. So they are supplementary. All righty, so just write that. We know what A is. What's A? They told us 60 plus the measure of angle C equals 180. Well, if I subtract 60 from both sides, the measure of angle C is 120. There you go. See how that works? Now, what do I know about angle B? Well, I know angle B is opposite angle D. So that means that angle B and angle D are supplementary. So I'm just going to write down what I know. They told me what angle D was. They said it was 95. So 95 angle D plus the measure of angle B equals 180. I just subtract 95 from both sides. And look what I get. The measure of angle B equals, well, 180 minus 95 is 85. All right. That's pretty easy. Why? It's pretty easy because they give me numbers, right? So really what we have to learn how to do, fellas, is we have to take our information and we have to be able to use it when they don't give us numbers, they give us variables. Because then you're getting good at algebra. So let's see what we got. Let's do one where we have algebra to do, right? So I have my circle, and I'm going to draw a quadrilateral. And this is A, B, C, D. So I have an inscribed quadrilateral. So really what I know is that the angles that are opposite are supplementary, right? So here's what they tell me. The measure of angle A is 58. The measure of angle B is 3y plus 4. The measure of angle C is 2x. And the measure of angle D is 2y plus 16. All right, now, before you even start, fellas, you'll notice A and C are opposite, B and D are opposite. You'll notice when they give you B, they used a Y, and when they give you D, they used a Y, right? Because they're the opposites. They couldn't mix the X and the Y. The X is with the 58. So if I label this picture correctly, I would put a 58 right here, and I'd put a 2X right here. And then what I would do is I would put a 3y plus 4, and I put a 2y plus 16. Now, what I know is that the two blue angles are supplementary because they're opposite. And the two green angles are supplementary because they're opposite. So let's go figure out what X is, right? That's the blue angles, right? So what do I know about them? I know that angle C plus angle A equals 180. Everybody see how we did that? Does everybody see how we did that? Now solve that. Well, I'll subtract 58 from both sides. And I get 2x equals 122. Hey, fellas, what's angle C? It says angle C is 2x. Look at my equation. What's it say 2x is? 122, right? Yes? I'm done there. But if I wanted to know what X is, it would be 61, right? Now, let's do the green numbers. Let's figure out what Y is. Let's figure out what Y is. Well, I can only use Y's with Y's, so I know that angle B and angle D are supplementary. So B, 3y plus 4 plus 2y plus 16 equals 180. All righty, combine your like terms. What's a 3y and a 2y? 5y. And what's 4 and 16? Well, that would be 20. And then you just solve that. You can subtract 20 from both sides. And you end up with 5y equals 160. And to get y, you just take 5, divide both sides by 5, and you get y equals 32. Now, that will be good if that works out, right? So let's see if that works out. Let's put it in there. Well, I know angle B. I know angle B is 3y plus 4. So 3 times 32 plus 4. All right? So 3 times 32 is what? 96 plus 4. Well, that's 100. So I know angle B is 100. So what does angle D have to be, fellas?
80.
Let's see if it works out. Let's see if it works out. Let's substitute 32. Let's substitute 32 into 2y plus 16. All righty. Well, so I got 2 times 32 plus 16. 2 times 32 is 64 plus 16. And 64 plus 16 is 80. Very good. So 100 plus 80 equals 180. Fellas, does that make sense to you guys? All righty. So you learned 2 things today. that you're going to use. Ready? First thing you learned is in an inscribed triangle, if the angle intercepts a diameter, the triangle is right. Why? Because the angle would be 90 degrees. So that's the first thing you learned today. The second thing you learned today, in an inscribed quadrilateral, the opposite angles are supplementary. What's that mean? They add up to 180. All right, does everybody got that? Is everybody good with that?
Yes, sir.
All righty, now pay attention. Pay attention. All right, I'm gonna stop recording. That's all for today with that. Let me make a few announcements. So let me stop recording.